my talk is called Looking Good, and we're looking using something called Qt Quick on the Raspberry Pi. And I'll explain why as we progress through the talk. So, I got the stand in the way. Okay, so first of all, we'll go through some background, explain a bit about graphics on the Pi, because that's really the focus of what I'm showing you today. How can we get nice, smooth, high-performance graphics on the Pi, but in a nice, easy-to-program way, which is fun for everyone. And I'll show you how to make a game. We'll look at some particle effects, which is quite pretty. And I'll talk a bit about the slide system you saw at the beginning of the jam. That was all running off of Raspberry Pi. So I'll show you how to make that and how we could possibly customize it. So first of all, Tail 2 processors. With the Raspberry Pi, there's actually two processors in there, well, two main ones. There's probably a few others. You've got the main CPU. This is the one everyone's mostly familiar with. We know it runs, it's okay, 700 megahertz, but it feels a bit slow for a computer. But it's probably what was in mobile phones, I guess, a few years ago. Back when if you had something like a HTC Wildfire, that wasn't much more powerful than this. And this runs your operating system and does all your general processing. But the other part, which isn't always, we don't always talk about, is the GPU, which is a Broadcom Video Core 4 running at 250 megahertz, which doesn't sound that great, but this is what's doing a lot of the magic inside the Pi. Some of the things it does includes, you can see it does all the video decoding. So if anyone here uses XBMC, you'll know that videos play quite smoothly. It all works quite well. It also does the audio. Any 3D graphics you've seen, I think some of the user interface in XBMC takes advantage of that. And it also, if anyone has the camera module here, does anyone have a camera module? A few people want it. So that's entirely running off the GPU, which is why it works so much better than a web camera. And you may have seen it can go capture as fast as I think is it 90 frames a second? So, and it can do that quite well and do some effects. It's all because there's a second processor there doing some really complicated maths for you. And it does mean that if you can use the camera and do other stuff alongside it quite effectively. So just to highlight how good the GPU is, I'm going to show what it's better than in terms of performance. So I'm sure plenty of people in the room recognize one of these, the good old Nintendo DS. I bet a fair number of you have one somewhere. How many of you have a Nintendo DS? Really? I would certainly expect the younger members of the audience to. Well, the Raspberry Pi is better than this by quite some margin. Anyone have any of these? It's not showing off too clearly, but there's the original Xbox, a PS2. Yeah, I know it's a few years old now, but once again, the Raspberry Pi is more powerful than that. For those of you technically inclined, I put the number of gigaflops in the corner, which is it's a rate of measurement, but basically the bigger, the more powerful the system in terms of its graphics. So, hold on. Oh, that's the 3DS. I almost forgot. And the Wii. How many people have a Wii here? Once again, probably not too much of a surprise, but it's still more powerful than a Wii. But I think it'll be the next one that might surprise you. We have here an iPad 2 and an iPad 4S. How many people have one of these? Oh, are we all Android lovers in the room? Anyway, the Pi is technically faster than this. So if you think that it's a slow device, that it can't do much, you're wrong. It's very powerful. You just need to be able to take advantage of this. So before we move on, it's 24 gigaflops to be precise. So it was 16 was the amount on the iPad. The only thing that can slow it down versus smaller mobile devices is your TV is quite a big resolution. So you probably noticed if you've got a fairly modern TV, it's 1920 by 1080, which is quite a lot of pixels, quite a lot of an area to fill. And the bigger the area you have to fill, the slower your graphics will generally become. So what we want to know is when you're generally using the Pi, you boot up X Windows, and it doesn't seem that fast. It seems quite slow. And maybe some of the things you run on it just don't seem that fast. So we have to look at what a Raspberry Pi is in reality. We all know what its aim is, but what is the chip inside there, the Broadcom chip? And it's just a media processor. First and foremost, the GPU takes up most of the silicon, the space. And the CPU was actually put in as there was room to fit it on there. Hence why it's not the most powerful, not the most current. So the things the Raspberry Pi is really good at is not so much general processing, it's all the other things you can do with it. And if you can use those rather than the main CPU, you can get really nice results. So I'm sure you're going to go, you now know about the power, but you're going to want this power. So we're going to look at graphics, and in particular, I say the 3D graphics is something this is really good at. So let's talk a bit about 3D graphics. 3D graphics basically boils down to two main things. We have triangles and shaders. Now, you're wondering why triangles? So you can build almost any shape you want out of triangles. And so that allows you to form objects. And then shaders are like the texture, what you make the surface of that object. So to give you some examples, I'll take a well-known film, and we'll see what a wireframe is. Now you notice this isn't triangles, it's actually squares, but obviously you can easily make a square out of triangles. So you can see the shape of Linguini from Ratatouille this is probably just a crude model of how it's made. So you can see the shape from all of this. Obviously these things can get quite detailed, and here's a shape made out of triangles, and you can see the whole shape, but you can't see the texture here. So triangles make up the shape. But for the purpose of what I'm going to show you, nothing's going to be this complicated. In fact, this is the only shape we're going to form. So we can fill it like this. So the other thing was shaders. Once again, returning to the same film, a shader is a little program that runs on the GPU. And it runs independent of the CPU, and it forms the surface texture. So here's something called a hypertexture. So there's a little algorithm that kind of defines the object you can see on the left. It's quite common that I think you can find it in a few books. But you can then use it, apply it, give it some color, and it can be something like, in this case, it's the texture of the bread in this baguette. So you combine these things, and as you can see, it lets you define anything. You can visualize a whole. This is the basics of filmmaking. It's the basics of computer graphics, your games, and all that. But the thing is, let's look at just a very simple shader here. So this is a one-line shader that doesn't do much. Can anyone guess what it does? Yes, it's not obvious, but actually it just makes something the color green. And yeah, you may notice, those of you who are mathematically inclined, that there was a vector in there. Maybe not quite a direction of magnitude, but this is all shaders are essentially, they're just maths equations. It's probably the most interesting form of maths you can do because it makes pretty pictures. But it's not, obviously takes some understanding just to understand how to build these. But if you do, there's a lot of power there. But as I say, don't worry. There are things that will use this and can use this power, but make it easier for you to develop. And this is what we're going to look at. So I'm going to introduce Qt 5. Now this is not something that you can just download onto your Raspberry Pi today. It's not there in the standard Raspbian distribution, although I think it should be, and I think it will be. So I'll just explain what it is. So it's this large multi-platform system for software development. It runs on Windows, it runs on Mac, it runs on Android, it runs on the Raspberry Pi. The idea is you write a program using Qt 5's components, and it should run on lots of different platforms. We're quite portable. But still not the reason why we're using it today so much. It's more the fact that in Qt 5, and at the tail end of 4, they added this ability for you to write these files called QML, which is nice and friendly, and then you can use JavaScript to program. And they made it, and they designed it in such a way that Qt can take advantage of the GPU, which can give us nice, fast graphics. And so what I want to do, first of all, I'll tell you how to install it, and then we'll look at what we can do with it. Now, I realized installing it wasn't quite as easy as I thought, because initially, let's say, there is a version of it on Raspbian today, version 4.8 is within Wheezy. I think there's a new version of Raspbian going to come out at some point using the next Debian distribution called Jessie, and that should be 5.2.1, which is what I'm going to use today. You can compile it from source, but I wouldn't recommend it. But I have actually found some packages on the internet and produced some installation instructions that let you install it today and start using it today. So the instructions, initially I thought it would just be something like that, but then it turned out you needed to do that and then that, which I thought was maybe a bit too complicated just to put in a few slides. So I decided to make a script to do it for you. So as part of this presentation, if you can type these commands onto your Pi, and it'll get you a copy of everything I show you today. And you can just run that script, and it will take care of that whole process for you. So let's just have a little look at a very, very simple piece of QML. So all this does here is we're going to define a rectangle. I've given it the size of a screen, in this case. And I've put another rectangle in it, which is just in the center. It's 256 by 256, and it's blue. But just so we can understand what all of this is, we have imports at the top. This kind of brings in the features. So you always need this one line just to sort of allow you to program in QQuick. And then you have these kind of objects. It sort of looks a bit like CSS for anyone who's done HTML programming, web development. And we have all these attributes. So you can write, so you have text files like this, and this gives the description, the appearance. And then later on, we can add code to this. But even without any code, you can do quite fancy things, or even with only just a very little bit of code, which is what I'm going to show you. So to save swapping back and forth, what I'm going to do is I'm going to show you 3 sample pieces of code. Sorry, I'll show you the output of 3 pieces of code, and then we'll talk about how they're made. So, 1 second. Have I got a heckler? So I'm going to start with a very, very simple game. This is something that my children absolutely love. It was just something simple I made, but somehow it manages to provide loads of amusement. All it is you press a few keys, they appear at random positions in random colors and just fade away. It's not much to look at, but it's amazing how much amusement it can provide to young children. And there's probably, I don't know, less than 10 lines of code in that. So the other thing I want to show you, when you build up an impressiveness, I want to show you a shiny graphic effect, this particles effect, which is quite pretty. I think there's actually 0 lines of code in that, but you can control all the behavior in quite an easy way. This is sort of incomplete, because what I was really aiming for is, if anyone remembers the old Odeon cinema adverts, the pre-roll idents, there was one that was sort of orange flashing sparks, and I was trying to recreate that, but I only got so far into it. It actually turned out, I thought it was all computer generated, but it actually turns out it was someone cutting steel, hence why all the sparks danced about. So the one other thing, so you should have already seen this, is of course, we had this running at the start, which is all powered off the Raspberry Pi using the environment. That's actually a shader running there, one that runs on the Pi. I had, depending on the resolution of your projector or your monitor, it runs at different speeds. But this is quite smooth. I actually did this whole presentation originally, I did it in Google Docs, and it looks awful. It was really slow. This rectangle jutted in and the text jutted in, and I thought, I'm sure a Raspberry Pi could do that smoother and better, so I did it on the Pi. As you can see, there's a little bit of fading in, sort of zooming in on the images, all the graphics come in smooth. It looks nice. It runs just as well on a PC as on a Pi. So, the big question now is, how do we do all this? Right, so what I've done is, because it's never easy to follow code, I've actually put a whole load of comments in this. So first of all, can everyone read the text, or is it a little bit hard to read? Are we squinting at the back there? Right. Better? It's good. Right. So, for the purposes of this, I don't know if there is a... Okay, so for the purpose of this, one thing that's provided is an editor environment called Qt Creator. I'm running this on my desktop PC, but you can also get it for your... I think it may actually run on the Pi as well. So what I've kind of done is, because all the code can work on your PC as well as your Pi, you can develop on your PC, then take it to the Pi, or you can edit it on the Pi. This editor just makes it easy because you get all the integrated help and the highlighting of the code. So, we'll start with a little simple game. I started with a rectangle. You give things IDs to be able to refer to them. I made the width and the height full screen, gave it a nice white background. Then the idea is, when you press a key, here's a tiny bit of code. When you press a key, it's going to create an object. all it does there is there's a little bit of code to dynamically create it and set the text from whatever you typed in. Okay, but that doesn't do everything. So as you can see, that just literally creates the object. What I have here then is the actual appearance, and you can customize this. I'd probably say, if you want to start fiddling with this, download this, change this char.qml file. This is what gets created each time. And what you change here will change the appearance of those characters. You can change the font. I give it like a random size, a random color. So I'm just using like JavaScript syntax on the lines here. And there's all kinds of different properties. I gave it an outline to make it a bit more cartoon-like. I used a bit of maths to give it like a random location on the screen and like a random rotation. But you can come here and just customize this. And then the one thing was the animation. So I've got a number animation which fades. So we have this idea of opacity. When something's 1, it's fully visible. When it's 0, it's invisible. So what we do is we fade it out over 5 seconds. And there's a tiny bit of code here that just says, oh, when you finish fading out, destroy this object. Because otherwise you're going to have hundreds of objects everywhere, and it slows down over time. But there we are. It's a simple game. It runs really well. You can run it for hours. You can have loads of characters on screen, and it doesn't really slow down much. So that's the game. In some ways, actually, maybe the particles are a bit simpler. So start with a black rectangle, and then there's this thing called particle systems, and you can have different kinds of particles. There's all kinds of properties you set in that affect the appearance, which means you can go from what you've seen. I kind of did this bit shooting up from the bottom with a bit of gravity, but you could have them spraying out from the middle or spraying out from a side. You can make the image whatever you want. You could, I don't know, spray dogs off the left-hand side of the screen if you want. It's however you want to, whatever you want to do. And it's probably great just to take something like this and change it. As you can see, I just use an image there as the source, but you can change it to whatever you want. It could be stars. There's some built-in ones if you're having problems transferring files. And what I do is I change the transparency and I change how things appeared. You know, when they appear, they kind of the little particles grow initially. And then there's sort of slightly different transparency, and then apply some gravity. And you can control how many you send out per second. So you can have an emitter. And there's 300 a second. They can last they last 1.5 seconds, but minus or plus another 600 milliseconds. So it's 0.6 seconds, and they can vary in size randomly. So that gives the whole, no two particles are necessary, have to look the same. So you see it fire up, and I tried to get a kind of natural effect. But you can come in here, take this code and change it, change the color, change the sizes, change what it does. And I just put a caption at the top, some text. The idea is with QML there's a whole load of objects. You put the object in there, you make it appear how you want, where it goes, and then you can use code. You can use the ID as sort of refer to it in code and do things, move things across the screen. So the slightly more sophisticated example of this is you have the presentation system. I'm not going to go into all the details of this, but one interesting thing you can do is the initial bit's all custom, but after a while, what I've done each slide, you can make reusable components. So even if you're not too experienced, you can always have someone make a component for you and then use it. So all the talk slides share the same bit of code, and I just put a few things into it, and then that customizes how it appears. So I can reuse this. And all it is, it's just a just another file. I put some properties to the side, so these are the bits that can be customized. And inside it just does lots of, well, it's a bit of code, but mostly it puts some images in there, or a gradient if there's no image, some title text. I define it all up here, what I want it to look like. So all the rectangles, the text at the top, the text at the bottom. So all the bits to give it the look of a slide. And then I have animations. So you can have parallel animations. You can have more than one thing running at once. You can have sequential animations which just do one thing then do another. And you can combine them. So the zooming effect in the backdrop, I just scale it from 1 to be 1.2, which is just slightly bigger, and do that over 10 seconds. So as you saw on some of the slides with the images, they just seem to zoom in slowly. And this is all animations. And you can build these up. You do them sequentially or in parallel. You change all the objects and you get a kind of effect of that, get some animation. And so underneath, Qt's taking care of doing it all quickly and smoothly. There's also, there are some games written in QML. I think mostly by the people who made the system, but I think if you Google one called Flying Bus, there's a little, I think it was designed for mobile originally, but there's a little bus, goes along, you click on it to avoid objects by moving the bus up or down on, well, attaching a balloon to it, which makes the bus float. Sounds a bit crazy. Not sure if I got it on here to show. But you can do sophisticated stuff. And to kind of finish it off, because I think it's probably best to look at this code in your own time rather than me trying to explain it line for line. I'm going to show something that perhaps some of you haven't seen since the early days of the Raspberry Pi. Back when it was still fairly new, there was a quite interesting demo that was shown on, I think it was shown on the Raspberry Pi website. Hold on. Right, might take a few seconds to get started. So some of you maybe haven't seen this for about 2 years. Does anyone ever remember seeing this? Was it that long ago? So this is all made in QML, running on a Raspberry Pi. And if I can get enough space for my mouse. Okay, you have a surface which the mouse doesn't work on. You can see all these like effects. There's some particle effects. There's a fairly pretty shader. And it's this kind of performance you're used to from your Pi, because it's pretty smooth, pretty fast. You've maybe seen something similar to this on XBMC. But this is what you can do with QML. And you can download this, look at the code, build up. It's not something I've done. Let's say it was one of the early demos. And this just shows how powerful it is. You can see there that in the backdrop, it's all being faded out. If you look carefully, you'll see that there's kind of light effects on the covers there, and the particles spraying out the back. All pretty sophisticated, and as you can see, the frames per second up there is 60. So that's pretty much as fast as it needs to, as you can display on a TV. So I think it's worth downloading, experimenting with this, because it's maybe not as easy to work with as Scratch, but it's quite visual. And if you could build a presentation system quite easily, it's much more exciting than PowerPoint. Okay, so for the reference, the code is available here. What I recommend, we'll tweak this afterwards if anyone's sort of desperately reaching for a pen, but go download it, go have a look at it, go experiment with it. I put loads of comments in there just to explain what's going on, because I didn't want to bore you spending hours trying to explain all my code. But it's actually not much code. It's a lot about setting how you want it to look and then telling it what actions you want it to take. And thank you.